Hi, hello. I've got our last quiz of our polynomials unit. I'm just going to go through the problems here. Please let me know if there's anything tricky or if I make a mistake. That's always possible. So, first is just simplifying that some sort of radical expression. This looks like something you might end up with if you're doing the quadratic formula. And what I notice is that all three of those terms that are outside the square root are divisible by 3. So all we can do is knock that down. 18 divided by 3, 9 divided by 3, just copy the I root 10 down. And 6 divided by 3 is 2. That's as good as it gets. So just leave that one there. Second problem, we've just got some quadratic formula problems, and then we're asked to simplify it. So we've got something like 4 theta squared plus 8 theta minus 3. So then we use the quadratic formula, negative b, which is just the number. Some people mix that up. B is the number in front of the variable. Plus or minus the square root of b squared minus 4 times a times c. Make sure you grab all of the c value. The c value is a negative 3. All divided by 2a. Then you'll see how we get this down to a version that looks similar to what we just did in the first problem. 4 times 4 is 16, and then 16 times 3 is 48. Like so. 2 times 4 is 8. So theta is negative 8 plus or minus. That'll be 112. Let's see. What goes into 112? I think the best is just 4. I could be wrong. So let's see. 4 times 25 would be 100. So I got 3 more 4s. So 4 times 28. Looks like I could have actually pulled out a 16. How do I know that? Well, because 28 has another factor of 4. So let's scoot my face up there. Let's do, that's from the first 4. And then 28 is 4 times 7. So again, I could have jumped, let me show you. This 4 right here will multiply to make it 4, because 2 times 2. Okay, I could have jumped to that from here if I had noticed that 7 times 16 is 112. 16 times 7, and that makes sense. So those are two different options. This is option number 1 here. This is option number 2 there. Gets you to the same place in the end. And then we can simplify because they're all divisible by 4. 8 divided by 4. 4 divided by 4 is 1, so I just write 1 root 7, or just root 7. And 8 divided by 4 is 2. So that was quadratic formula, and then simplify radical form. Let's make a little space here. We had another quadratic formula 1, 2w squared minus w plus 8. So w equals the opposite of b. Well, that's just 1, because b is negative 1 here, so the opposite is positive 1. B squared minus 4ac over 2a. Makes sense. Then we're just playing our simplifying game. I do all the basic operations first. So negative 1 squared is positive 1. 2 times 2 is 4. And then 4 times 2 is 8. Times 8 is 64. Now we'll have a negative number under the square root. I don't think 63 has any perfect squares that go into it. No, it doesn't seem to. So you can just check, on your calculator. Does 4 go into it? Does 9 go into it? Does 16, 25, 36, 49. Just keep going through the perfect squares and see if they go into it. Nothing does. But there's a small thing that I want you to do here. Really lame joke is that you don't know the square root of a negative number, but I do. And the lame idea there is that we just literally use the letter I to mean the square root of a negative number. Even though you can't do it, I can. And that's it. That's as simplified as it goes. All right. Next problem is a wonderful problem. What we know is that x plus 4 is a factor of some big, ugly polynomial. 2x to the fifth plus 8x to the fourth plus kx to the third minus 8x squared plus 4x minus 48. Okay? And the hard way to do this problem is to try to divide. Because if something is a factor, you know that you can say, oh, I'm going to divide this by x plus 4. But that's really hard because it's a fifth degree polynomial and because you've got to worry about how are you going to deal with this k value there. So that's tricky. The other way to do it is to realize that if I tell you a factor, I also tell you a zero or a root or an x-intercept. Zero, root, x-intercept. Those are all synonyms. And that's a much easier way to do it because that means that all I need to do is plug in -4 for all of my x's. And I don't know k, so I'm still writing k down as a letter, but I'm writing -4 to replace all the other x's. And what does it mean to be a zero? What does it mean to be an x-intercept? It means it all equals 0 when you plug in that number. I'm going to grab a calculator because I don't feel like doing all that stuff. So what I'll do is I'll type in everything. I'll type in everything except the k part. Give me one sec. And I'll show you what it looks like. Okay, so check out what I typed in here. So I typed in the whole polynomial, right, with all the -4s. I don't know why somebody did all those 6s before, but that's what happens sometimes. Okay, so I did all that, and that gives me -192. So -192 is all the stuff that does not have a k. -4 to the third power is -64, and so you can do -64 times k, and this equals 0. So let's solve for k. So -64k is 192. 192 divided by 64 is 3. So k is equal to -3. And just to kind of reinforce the idea here, if I actually go on Desmos here and I type in my wonderful polynomial with a -3 for the k value, what I hope you notice now, let me clear out my drawing, is that it hits the x-axis at -4, 0. And the clue that I was given in the problem is that x plus 4 is a factor. Okay, but if x plus 4 is a factor, then -4 is a 0. It also has a couple other zeros, but that's not relevant. All right, on number 3, we're working on calculating an exact equation. And here is what it looks like. It's something like this. It goes through 0 linearly, and then it goes through 8 like a cubic right there. So what I want you to notice is that when it goes through something like a straight line, that means that that factor is raised to the first power. When it goes through a root like a curvy squiggle like that, it's a factor of a cubic equation, it's to the third power. So I can set up my equation already like this. It's x minus 0 to the first power because it touches 0 like a line. And then the drawing, it's labeled that this is 8 right there. It touches 8 like a cubic. The thing I don't know is how far down does it go? This part right here is a mystery. So it tells me that there's a point of 3 comma -45. If I just type in my equation, x times x minus 8 to the third power, it goes really far down. But I want to choose the exact equation that lands on 3 comma -45. So what I do is I just put a letter that I don't know in front of the problem. Multiplying your equation will make it taller or shorter. And then I take the clue that I have of 3 and -45, and I say the y value is -45, and the x value is 3. So I plug it in for both of the x values. -45 is a times 3 times negative 5 to the third power. So that's 5 to the third is 125. So times 3 is 375 a. So then a is 2 negatives cancel. 45 over 375. So watch what happens now as I type this in. And if I scoot down a little bit, you'll see that it goes through the point 3. Wait, come on, land on it. 3 comma negative 45. So it goes right through that point. And it also hits the 0 as a straight line, and it hits 8 as a squiggle. So it matches the exact picture. Okay, great. So then one more problem just like this. We're almost done. Hang with me. So this other one looks sort of similar. I've got a picture where it swoops down and hits negative 5 like that, and then hits 6 like that. And it has a y-intercept of 204. So this is negative 5, this is 6. So I can set it up basically the same way. I don't know what my stretch is. I know I'm going to hit x plus 5 to account for the negative 5 and x minus 6. But x minus 6 goes through like a straight line. X equals negative 5 bounces off like a parabola. So I make that part parabolic. I put a 2 on it to make it parabolic. And then it tells me the y-intercept is 204. So I put a 204 there. And I put a 0 for both my x values. We're almost done. 204 equals a, 5 squared, negative 6. 204 equals a, 6 times 25 is 150 with a negative. So a is 204 over negative 150. I think I should have written out, the full equation on the previous one. I guess I typed it in, but I didn't handwrite it. Just make sure that if I ask you for an exact equation, you actually write out the whole darn thing. All right, last one here. We're going to look at just an equation. I'm going to do this on Desmos, but you need to know how to do this on your graphing calculator. Okay, so just make sure you know how to do it. We have a picture of 0.3x to the fifth minus 1.1x to the fourth plus 6x minus 4.4. We have this beautiful picture here. And we're asked to figure out a couple things about this. We're asked to find where it equals 100. Okay, so you're going to go all the way up here to where it equals 100. I like to type in y equals 100 as a separate equation and find where they intersect each other. So now I know that when x is 4.377, the y value is 100. The next question is asking us about the interval from 0 to 3. So I'm just going to zoom in on the interval from 0 to 3. And it wants to know the local maximum. So this point is the highest it gets in 0 to 3. So that's my maximum. Give both of the coordinates. The maximum is 1.367, comma 1.393. And this point's called the local minimum down there. Notice I call them local because they're not bigger than all other points on the graph. If I zoom out, the graph keeps going up and it keeps going down. But they are bigger than all the other points that are nearby. So they are local maximum and local minimum. Okay, thanks for watching. Let me know if you got any questions. Happy to help.